All right, I'm going to roll through these as quickly as possible for you. Please make sure you've tried them before you watch this video. At least try one, then pause it and watch it. Don't just do this for the first time right now. All right. One thing I got to warn you about here, and I hope you're paying attention, because if you turn it in and it's wrong, you're just copying. I know you're not listening to me. All right, and you're going to lose points. My choices here are different than yours. Notice how mine goes translation, reflection, rotation, dilation. Yours goes dilation, reflection, translation, rotation. So everybody, our choices are in different order, so I'm not going to circle the letters. I'm not going to circle the letters. I'm only going to circle the word or whatever the choice is. Okay, in this case here, I think they're the same in this one here, so it doesn't matter. But yeah, these are different. So they're all out of order. We got to make sure we pick the right choice. Which transformation does not preserve orientation? Well, reflections do not preserve orientation, because when you flip over, the order changes. Okay, go back and look that up if you're not sure. That will be on your quiz. That will be on your quiz 4. Which figure has one and only one line of symmetry? It is the isosceles triangle. An isosceles triangle, which we've been taking a look at here, you would only be able to go right down the middle. Okay, that's the only line of symmetry you would have there, because these two sides are equal. This side is not necessarily equal, so you'd have one line of symmetry. It's the isosceles triangle there. Which figure has 120-degree rotational symmetry? 120 degrees. You just divide by 360 to see how many sides you'd have. 360 divided by 120, and since it's 3, that means you can rotate it 3 different ways and have symmetry. So that's going to be a triangle, and it's got to be equilateral, or else it's not going to have symmetry at all, right? It's not going to have rotational symmetry unless it's an equilateral triangle. All right, so equilateral triangle has, I'll draw that picture there, equilateral triangle has rotational symmetry of 120 degrees, because that's an order of 3. That's review. This is a review. We haven't done this in a while. That means you can turn it 3 different ways. 1, 2, 3. Right? You can turn your paper, draw an equilateral triangle, and turn your paper, rotate your paper, and you could see the same exact triangle 3 different ways. The order is 3. That's why it's 120-degree rotational symmetry. Which type of symmetry, if any, does regular hexagon ABCDEF have? Well, let's see. It has a point symmetry. Point would be in the middle, and you could rotate it. You could rotate it upside down as long as it's regular, as long as it's equal on all the sides. All right, so it does have point symmetry. Does it have line symmetry? Yeah, I could draw a line of symmetry right there, right? If you fold along that line, right? Fold along that line, it does land on itself, so it does have point and line symmetry, and that is choice B. Okay, this one here, again, the choices are all different here. Which of the following is equivalent to this? So we have a translation 3-5. I just can't see the screen. I gotta keep looking down. Translation 3-5, translation 4, -4. These, the 3 and the 4, are the x's. So we're gonna add 3. I'm sorry, you're gonna add 4, then you're gonna add 3. So what are you really doing? You're adding 7. So really it's a T7, and then you're gonna take away 4, and then you're gonna add 5. Take away 4 and add 5. So if you're taking away 4 and adding 5, you're really just adding 1. So really just combine the x's and combine the y's, and that's going to be a T7-1, and that's going to be this choice right here, which is your choice A. It's your choice A. If triangle JKL is congruent to MNO, which statement is always true? You guys got to go by the letters. So it's going to be JL congruent to ON. JL congruent to MO. It's going to be this one right here. Again, the choices are out of order. It's your choice C. And why is that? Well, J and L is the first letter and the last letter, and M and O is the first letter and the last letter. So if you were to draw the 2 triangles, you got to make sure the the letters match up so it's corresponding. Okay? So first letter, last letter, first letter, last letter. That's all it really is. Okay? In the diagram below, triangle ABC is congruent. So they're telling us that these triangles are congruent to each other. These triangles are congruent to each other. Which 2 statements identify corresponding congruent parts? So what are going to be the corresponding parts? If these are congruent triangles, then X would correspond to A, right? Y would correspond to B, and Z would correspond to C. Okay, so X would correspond, let's do a different color. Y would correspond to B, and Z would correspond to C. So the correct answer is going to be BC is congruent to YZ, and angle A is congruent to angle X. All right, we already know angle A and X, they're both blue. Okay, it's just a rotation, X and A correspond, and then BC and YZ, BC and YZ, well, that connects the red and the green, So you use different colors or different shapes to make sure you match the corresponding sides and corresponding angles, okay? That's just corresponding sides and corresponding angles. And again, you can go by the letters, okay? So A and X, first letter, BC, second letter, last letter, YZ, second letter, last letter. See how it's corresponding? Those two are very similar. Given triangle ABD, BC is the perpendicular bisector of AD. So there's two words there, perpendicular and bisector. Now perpendicular means it forms right angles. So we have a right angle here and we have a right angle here. Bisector means cuts into two equal parts. What's being bisected? AD is being bisected. So AD is bisected. AD, that red line I just drew, that red segment is cut into two equal parts. AC is congruent to CD. All right? We also have the shared side, so we know these are congruent triangles. So which statement cannot always be proven? What cannot always be proven? AC is congruent to DC. Well, that is true. So that's not going to be the one, right? That's not going to be the answer because it says which one is not proven. Triangle ABC, congruent to DBC. That is true. Because of side angle side. So these are congruent triangles. Therefore, we want the one that's not, again. Angle ACB is congruent to DCB. Okay, so that one is true because those are the right angles. And then BC is congruent to CD. Well, that's not true. BC and CD, those would not necessarily be congruent. They might be, but we don't know for sure. We know that BC is congruent to itself, and we know that CD and AC are congruent, but we don't know for sure that BC is congruent to CD. You were supposed to pick the one again, and that's your choice A. Okay? So make sure you realize that you are choosing the right answer, not the right choice number, A, B, C, D. All right, in the diagram below, AB is parallel to CD. So AB is parallel to CD. Parallel lines form alternate interior angles with that transversal. See the transversal? So I know that this angle is congruent to this angle. Then they tell us angle ABC. They tell us angle ABC is congruent to CDA, this angle here. So we know this angle is congruent to this angle, and we know this angle is congruent to this angle based on the given information, okay? Which method can be used to prove that they're congruent? Well, we have the shared side. And if you look carefully, what's this? Angle, side. Angle, side. We don't have this side. If you were thinking these sides, we don't have AB and DC congruent. They're parallel. That's not congruent. Just because they're parallel, meaning they don't intersect, right? That doesn't mean they're congruent. They don't have to be the same length. So we don't have the sides. We only have angle, side in our nice little Christmas diagram here. So we have angle, side. That's my choice A. It's your choice. Flip the page here. It's your choice B. It was your choice B. It's not that one. It's not that one. It's not that one. It's just your choice B. All right. Which transformation is equivalent to composite line reflection? This. Okay, so we have a reflection. Let's draw a little picture here. A reflection over the y equals x line That's the y equals x line, and then the y-axis. So I'm going to draw a different color. The y equals x line, and then the y-axis. If you reflect over those are intersecting lines. We had a whole lesson on this. If you reflect over intersecting lines, double reflection, 2 reflections over intersecting lines, the thing will rotate. Okay, so that's just a memorization, or you can actually do it. All right, it's going to be a rotation. A double reflection over intersecting lines is a rotation. Double reflection over parallel lines is going to be a translation. All right, so this is going to be a rotation, and that was choice C for you. We both had choice C. How nice. What is the image of rotation 180? -4, -7. Well, rotation negative 180 is the same as 180. You do 2 90s. Okay, so we're going to flip. Every 90 you flip them. So it's -4, 7, then it goes to 7, 4, then it goes to 4, 7. So it's going to be 4, 7, and we change the signs. We change the signs because you're going from quadrant 3 to quadrant 1. If you're doing 180, think about that. This is in quadrant 3. Now you're going to quadrant 1. It's got to be positive, if you have any understanding of rotations. How about a reflection over the x-axis? You just change the sign of the y. Just change the sign of the y. So 4, 7. Make sure you're studying your transformations. 1, 1. First we do the rotation 90. 1, 1 becomes -1, 1. Because we're going from quadrant 1 to quadrant 2. Quadrant 1 to quadrant 2. All right, that's -1, 1. And then reflection over the x-axis changes the sign of the y again. So now it's going to be -1, -1. So -1, -1 would be the final answer there. -1, -1. In the diagram, a parallelogram Fred shown below, ED is extended to A, AF is drawn such that AF is congruent to DF. Okay, if AF is congruent to DF, then I know angle A is congruent to angle D. So those are congruent. Angle R is 124. Okay, if this is 124, this must be 124. Okay, in a parallelogram, the opposite sides are going to be, the opposite angles are going to be congruent. So we have 124, 124. And then if that's 124, we know we have a linear pair, right? So we know this is going to be 56. Because you know you got the 180 right here. You got the 180 right there. So that's 180 total. That's going to be 56. And then AFD is this angle up here. So if this is also 56, so we have these two angles at 56. 56 plus 56 is 112. And what's left over for angle F? Well, the 3 angles of a triangle add up to 180. So it's 180 minus 112, which is going to give us 68. So the answer to this one is 68, because it's an isosceles triangle, 2 equal angles, and then the angle at the top would not be equal. It's whatever's left over. In 15 here, which sequence of transformations maps figure 1 onto figure 2 and then figure 2 onto figure 3? So we go from here to here. So that's going to be from there to there is because it didn't flip, it just slid over. That's going to be a translation. And then from here to here is a rotation. So it's a translation followed by a rotation, and that's your choice A. It's my choice B. A translation followed by a rotation, and again, it was your choice A. All right, your choice A. Steve drew line segments A, B, C, D, E, F, G, B, F, and C, F as shown diagram below. Scalene triangle. Scalene just means different sides, different length sides is formed. Which statement will allow Steve to prove we have parallel lines? Okay, so what's going to prove parallel? Well, the only way to prove parallel, and again, this is a little bit more advanced than what you're going to need to do on tomorrow's quiz, so we could even omit this one, but to prove parallel, we are going to be doing this. You would do a, just make sure you have alternate interior angles, okay? So EFB congruent to CFB. There's alternate interior angles there. So that would be, so EFB and CFB. All right. would that prove that these are parallel, EFG there? Okay, and then ABF congruent to BFC. That's not alternate interior there, so that's not it. CFG, gotta redo this. CFG congruent to FCB. Okay, yep, there we go. CFG congruent to FCB. That would be the alternate interior angles that we're looking for. Okay, right there. See the alternate interior angles? You have this cut by a transversal right there. All right, and then the alternate interior angles are congruent, and those are them right there. So that's the statement that's gonna allow Steve to prove that these two segments are parallel. All right, we got two proofs here. All right, I don't have a lot of room. I'm going to do my statements on one side, reasons on the other. I didn't set this up like I have it set up on yours. So we're going to do statements over here. And then we're going to do reasons over here. All right, so our first statement, we're just going to draw a line down the middle, right? Pretend the picture isn't in the way. All right, so we have BD bisects angle ABC, and the reason is given. Okay, so what does that mean? Now you could put your given, you might have put your other given in there, that's fine. I'm going to make a statement based on this. BD bisects angle ABC. So there's angle ABC, and that angle is cut into two congruent angles. So we should say that angle CBA is congruent to angle ABD. And that's definition of angle bisector. Okay? Then I'm going to put my other given in. BD is perpendicular to AC. Perpendicular gives me right angles, right? That's given. Okay. So angle BDC and angle BDA are right angles. All right, and the reason they are right angles is definition of perpendicular. Now we can say they are congruent. Angle BDC is congruent to angle BDA, and that is because of, why are they congruent? Well, all right angles are congruent. Okay, and then I'll erase this. I'm just going to write over this, and then I'll erase it for the next one. All right, so now we have angle. We just need the shared side there. So I think you guys got that one. BD is congruent to BD, and that's going to be the reflexive property. Reflexive property. And then I have the triangles are congruent. Triangle BDC is congruent to triangle BDA, and that's by angle side angle. And then Y is AB. Y is AB congruent to BC, CB. Y is, so statement 8, AB is congruent to CB, and the reason is CP, CTC. Because they are corresponding parts of the congruent triangles that we already showed. So we showed congruent triangles, and then the last step is just the CP-CTC for what we want. All right. Now we got one more quick proof here. Again, it's going to be CP-CTC. This one's very similar. So we have, I can extend my page now. So we have statements, and we have reasons. Number one is PQ. I'll tell you what, to save you time in the video, what I'm going to do is I'm just going to put this right here, I'm going to draw an arrow to save us time. Obviously, the reason is given. I'm going to put those all in. Say, well, statement 2 is also given. Statement 3 is also given. All right. So let's just start writing actual statements here, because your order may be different anyways, right? We're not matching the proof perfectly. All right, so we have perpendicular. That forms right angle. So angle Q and angle S, angle Q or angle S and angle Q are right angles. Okay, and that's definition of perpendicular. And then we're going to say angle S is congruent to angle Q. And that's going to be all right angles are congruent. Can't write on this thing. All right. Then we marked that. Then we have R is the midpoint of QS. Well, if R is the middle point of QS, then QR and SR. QR would be congruent to SR. And that's definition of midpoint. Definition of midpoint. Midpoint, I can't write. And then we got our vertical angles. So angle PRQ. Angle PRQ is congruent to angle TRS. And that's the vertical angles theorem, right? Vertical angles are congruent. All right. And of course we have congruent triangles now. Triangle PRQ. Triangle PRQ is congruent to triangle TRS, and that was by what? Angle side angle. Angle side angle. Oh my goodness. Angle side angle. And finally, angle P is congruent to angle T by CPCTC. And that's because they are corresponding angles of the congruent triangle. See how it's the first letter in the first letter? First letter, first letter. Well, then that must be true. They're corresponding. Okay? All right, just about done here. Last page. I'm just going to give you these, and you guys are going to have to, because I'm going to save you time here. You do reflection x-axis first, right? So negative 2, 3. Negative 2, 3. If you do the reflection x-axis first, you negate this. Again, change the sign of y. We already did this. So it's going to be negative 2, negative 3. And then you do the translation negative 3, negative 4. So you subtract 3 and subtract 4. Subtract 3 and subtract 4. You get negative 5, and then subtract 4, negative 7. So negative 5, negative 7. You don't even need the graph for this one. I just put it on there. And then the last one, you can do all 3 points. So you got to start with negative 1, 4. Negative 1, 4. First, you're going to reflect over the x-axis. Okay, that's going to be negative 1, negative 4. And then you're going to rotate 90. Oops. And you're going to rotate 90, and that's going to be, okay, so you're going from the third quadrant to the fourth quadrant. So it's going to be positive 4, negative 1. All right, and so that's how you do that one. Then I'm just going to give you the other one. So it's 4, negative 1, and then it's going to be 3, 7, reflects and becomes 3, negative 7. Okay, make sure you graph these as well, guys. Make sure you graph these. And then 3, negative 7 becomes well, that is in the fourth quadrant. That's going to the first quadrant. So 7, 3. Okay, so we have 4, negative 1. We have 7, 3, and then we have the last one is 5, 1. You rotate, or you reflect that, you get 5, -1. Again, that's in the fourth quadrant. Then you're going to the first quadrant, so you're going to get 1, 5. Remember, every 90-degree rotation, you switch the numbers, and then you move one quadrant. All right, so it's going to be 1, 5 there. All right, so you have 4, -1, 7, 3, and 1, 5. Plot those three and connect them. Plot these and connect them. All right, and you will see that this is the same thing as a reflection over the y = x line. It'll reflect, it'll be a reflection over this line. So you guys need to do the graph, or you're not getting full credit for this. You got to do the graph so you can see that it's a reflection over that line. We didn't really do that. We didn't do that. It just works out that way. All right, so I will see you for the quiz. Hopefully you got something out of this. See you then.